It says a graph is said to be symmetric with respect to, and with respect to, there is an it's not an acronym. Anyway, we usually replace with respect to with WRT, so that way you don't have to write with respect to, with respect to, with respect to each time. Okay? The x-axis, if for every point x, y on the graph, the point minus x, or x minus y, is also on the graph. That's your fold. So if this is the graph, and this red one is the graph of f of x, then that says if it's symmetric with respect to the x-axis, I would pick a point, and his mate, I come down to the x-axis, there's the x-axis, the same distance, and then his mate would have the same x value, but the opposite y value. The same x value, but the opposite y value. So that says what I want to do is graph this coordinate point, which is 3, 2, so that it is symmetric with respect to the x-axis. There's the x-axis. So that says, here's my coordinate point. I would go down 2, hit the axis. I would go then down 2, because that's a unit. There's his image. That's the point that is symmetric. And so this guy would have the same x value, which happens to be, what, 3? And the y value would be negative 2. So that says if 3, 2 is on the graph, then a point which is symmetric to 3, 2 would be 3, negative 2. And that would be true of anything which is symmetric with respect to the x-axis. Now, I deal in pictures, and that kind of helps me, because otherwise my puny brain would have a problem. And it says, okay, if I'm thinking x-axis symmetry, I would draw this picture. This axis, you'll see me do this every time we do a problem, is that I would take, that's my coordinate point x, y. If I want symmetric to the x-axis, I go vertical, I end up down here. That coordinate point would have the same x value, but I notice that the y value is opposite. And that's going to tell me how to work my problems and how to get a graph, essentially either to test how something is symmetric or to the x-axis, or create something which is symmetric to the x-axis. And that says, so in general, if x, y is on the graph of some function, and I'm going to say of f of x, then so is any coordinate point that would have the same x value but the opposite y value. So problem number 50 says, draw a complete graph that is symmetric with respect to the, in this case, and this should be x-axis. That must be a cut and paste, because this says x-axis. So that means that if I'm looking at coordinate points, the coordinate points I have are -4, 0, 0, 2, 5, 3. The symmetric points would do what? Make all the y's negative, right? So -4, 0, 0, -2, 5, -3. Keep x, change the sign on y. So this would be -4, 0, -2, and 5, in here someplace, -3. Now you see, if I were to fold this along the x-axis, this would lay on top of that. That's x-axis symmetry.